Hello, ninth graders. So we are today moving on, still talking about graphs. We're now going to talk about equations of lines and their graphs. So the equations or the graphs of linear functions. So there's a couple things that we talk about. One of the bigger things that we talk about is slope. And we've got a bunch of different forms that we also have with linear equations. This is something that was covered last year. So I'm going through this quickly with the assumption that it was taught last year. So if it's something that you feel less confident on, or I'm going too fast or you have a lot of questions, definitely feel free to use your additional help links that are available to you on the resources page. So let's go ahead and dive on in. The main thing with a linear function is that it has a constant rate of change. And rate of change is one of those really, really fancy words, which we have actually very many of. Rate of change is a really fancy word for slope. It's one of the many words that we have for slope. So we have rate of change. We also have a word gradient or incline. There's a lot of ways that we refer to slope. So having a constant rate of change means that the slope stays the same always. Think about our parabola and how steep or how the incline of that parabola looks, and notice that your incline isn't always the same. And there's some places in the parabola where the slope flattens out, right? And the idea with a line is that that slope always stays the same. One of my biggest pet peeves is when people refer to lines as, oh, it's the straight line. Because the rate of change is constant, all lines are straight. So saying a straight line is redundant. Don't say it. Okay, so we have a bunch of different forms and they each have their own purpose. The really cool thing about these forms is that they're always referred to in a way, almost always referred to in a way that tells you what it does. General form is the only one that it does not. So the general form of a line is ax plus by plus c equals 0. So your x and y's in here are here, and a, b, and c, let's do this in red, they all exist as integers, so they cannot be fractions. So I'm going to do this in the very mathy way and do it with like proper math notation. So you see this like bolded z is an integer. What that means is no fractions, because integers are not fractions. Okay, so they have to be whole numbers, integers. And more specifically, even a has to be greater than or equal to 0, but mostly greater than 0, which means that a has to be positive. So your x has to go in front, b has to go second, your c has to go last, your constant has to go last, and a cannot be negative. And neither of those guys can be fractions. So that's your general form. It tends to be the final form. We don't normally use this form for anything in terms of like manipulation. The only reason why we care about this form is because sometimes we're asked to put it in that form, but we never really start with that form. Your slope-intercept form is your starter form. It tends to be the form that we start with because almost always we're either given a slope and a point or we're given 2 points. And if we're given either of those, we have enough information to have, oh, sorry, I totally misspoke. Your point slope form is the starter form. Your slope-intercept form, this is why we never use pen, is your graphing form. So let's just continue with the thought process that we had before. I'm talking about the point slope form. So the point slope form is your starter form, the form that you tend to start with, because we tend to have either a slope and a point or 2 points. And either of those ways that we are given information is enough information for us to find a slope, and then we'll have a point. And you can use this for anything, for any line that you might create. The point slope form is y minus y1 equals m times x minus x1. If you want to go in and like highlight things, your y and your x here need to stay. A big common mistake that I see is that when we start to plug in things and plug in numbers, is that students tend to want to put in numbers for these y's and x's here, and you cannot put them in there because you need to have a y and x in order to have an equation. So you're plugging in a slope for m, and then your x1, y1 is your point. And this tends to be the form that we start in because we tend to have and start with a point and a slope. The slope-intercept form tends to be another final form. We almost never start with the slope-intercept form. We almost always end with that form, or maybe sometimes we're given it in that form. But more likely, the thing that's the most exciting about slope-intercept form is that you can graph it. It has a slope and it has a very specific point, and that specific point is your intercept, and this is your y-intercept. The reason why it's great for graphing is because as long as you have a point and a slope, you can then just like plot your point and then count your slope as you're graphing it. So your slope-intercept form is the nicest form for that purpose. And that's y equals mx plus b. So m is your slope, and b is not just any intercept, it is your y-intercept. So this is slope, and then x1, y1 is your point. Okay, so those are all of the different forms. In black, what the actual form is, in red, all of the information that you need to know with that form. General form is typically a final form that you need to get to. You never start with it. Your slope-intercept form, also a final form, specifically nice for graphing. And then your point-slope form tends to be what you start with all the time. So when you're starting to write linear equations, this formula should be the first thing that you write at the top of your page. Okay, so slope. We notice that slope is a common thing here as we're talking about lines. It's a constant slope. We see it in almost all of our equations. We talk about it all the time with lines because it's really important. Your slope is the rate of change. It is your gradient. It is the incline. It's how steep your graph is. And we tend to talk about it as your rise over your run. That's something I'm sure that you've heard a lot, rise over run. And what it means by rise is how much have you changed vertically? How much have you changed via the y-axis? So it's the change in your y values. And then your run is how you've changed horizontally, how you've changed in regards to the x-axis. So your run is your change in x. When we talk about change, this change in, you're going to start to notice maybe in science classes, this term or this symbol pop up. You're definitely going to see it in math class a lot. Delta is a Greek letter which mathematicians and scientists use to represent the idea of change. Something has changed. And so we use delta to signify that. So your change in y we call delta y. Over your change in x we call delta x. Okay, so these are all different ways to talk about slope. There is a formula. Your formula for slope is y2 minus y1 over x2 minus x1. So if you have 2 points, you have your difference in your y's, because change in something is a difference, a subtraction, over the difference in your x values. You do need to make sure that you keep it consistent. If you put the second point first for y, you need to make sure to put the second point first for x as well. You could also do y1 minus y2. That's totally fine as long as you keep it consistent, which means that your x1 then needs to go first, and then your x2 goes second. Again, this should all be review. Hopefully you remember it. We have 4 different types of slopes that we talk about. We have positive slopes, and positive slopes look like this. Yeah. So positive slope, we're reading it left to right, like Western languages are read left to right. So we read graphs like that. And it's rising as we're moving from left to right. We also have negative slopes, which look something like that. We also have slopes of 0, and a slope of 0 looks like this. It means that your rise was 0 and your run is just any number, but with a 0 in the numerator and a number in the denominator, it results in a slope of 0. Versus an undefined line, which looks something like this, would have a rise of infinite, a rise of any number you want, but a 0 for your run. A 0 in your denominator results in an undefined number. You cannot have a 0 in your denominator, so it results in a slope that is undefined. So that is why, is because your run is 0, and then you have a 0 in your denominator, and mathematicians freak out. I make a little face to remember this sometimes. This is your positive slope. This is your negative slope. This is your 0 slope. And this is your undefined slope. So you can make a little face to try and remember which ones are the slopes. Undefined and 0 gets messed up a lot. So hopefully maybe this image will visually help you remember which one is which. But these are the different types of slopes that you can have.